Hi, this is Shannon Matchick Myers, and today we're looking at an item from the Zill text for your quiz, if you're in my class, about setting up a differential equation. So we've got a cylindrical barrel, S feet in diameter, of weight W pounds, is floating in water, as shown in part A of this picture. After an initial depression, the barrel exhibits an up and down bobbing motion along a vertical line. So we're going to use part B to help us, figure out the measurements here. We want to determine a differential equation for the vertical displacement, which is y at t. And then if the origin is taken to be on the vertical axis at the surface of the water when the barrel is at rest. Then we're going to use Archimedes Principle about buoyancy, or upward force of the water on the barrel is equal to the weight of the water displaced. So we're going to assume that the downward direction is positive, that the weight density of water is 62.4 pounds per foot cubed, and that there is no resistance between the barrel and the water. So we can use y for y at t, and then the gravity, g, greater than 0 for acceleration due to gravity. So we're just keeping it in terms of g. All right, we don't have to plug in for gravity. I think that confused a few folks. All right, so let's check it out. Well, we have a cylinder, right? And we're looking at this. What we're looking for is we want to find the volume, correct? So here, the formula for the volume of a cylinder in general is what? Volume, good, would just be pi r squared times h. So now we need to figure out what to plug in. So s over 2 from this guy right here is the r, and then y at t right over here is going to be the y is going to be how much it's submerged. So we would have the height as y, and then the radius as s over 2, the quantity is going to be squared, and then we still have pi hanging out, and that's what our volume is equal to. So that ends up being equal to pi over 4 times s squared y. Good so far? All right, so now what we do is we apply Archimedes Principle. For Archimedes Principle, we want to go ahead and look at the upward force of water on the barrel, all right? And we set that equal to the weight of water displaced. So Archimedes, I'm just going to write this in. When we apply Archimedes Principle, all right, so now let's apply Archimedes Principle. So this upward force of water on the barrel in general is equal to the weight of the water displaced. Now that in turn is going to be equal to, we've been given that the weight density of the water is 62.4 pounds per foot cubed. So we'll put that in. And then we put in our volume measure, And that, in turn, when we simplify, 62.4 divided by 4 times pi, nope, just the 62.4 divided by 4. I think the answer is given in terms of pi. So we would have 15.6 pi s squared y. Now from this, okay, so that was Archimedes Principle. So this is what we get from Archimedes Principle. Now we need to apply Newton's second law. So when we apply Newton's second law, and this was all in 1.3 if you need to go back and look it up. So you end up getting W over G times the second derivative of y with respect to t is equal to what we just found, the upward force of water on the barrel. And that was equal to 15.6 pi s squared y. And then we can set that equal to 0 if we want. Actually, in the actual question, the second derivative was isolated. So we're going to end up getting the second derivative of y with respect to t is equal to 15.6 pi times s squared y times g all over w. And we're all done. All right. So that will be our final result. I hope you enjoyed the show. If you like what I'm doing, please press the like button and subscribe. And I hope you have a wonderful morning, afternoon, or evening. Bye.